Before we get on to our finalists, I'd like to introduce our keynote speaker. Dr. Robert Akins is a UCSD alum, and he's also the co-founder of Cymer. I don't want to go further into his background because I don't want to steal his thunder as he talks about the Cymer story, but please join me with a warm round of applause for Dr. Robert Akins. Thank you.
Well, thank you, Patrick. And hello, everyone. I'm a fellow UCSD student, just like many of you, and I think I'm going to be speaking mostly tonight to those of you that are students of UCSD. I was here for a long time. I was talking to some of the judges earlier. I think I still hold the record for the longest continuously enrolled full-time student at the school of 14 and a half years, during which time I got to take a lot of classes and get a lot of various degrees and meet a lot of great people who it turned out would be of tremendous importance to me in years that would follow. One of whom is Rick Sandstrom, the Cymer co-founder, who's not here tonight. There are rumors still circulating in the School of Engineering today that he may be the single most brilliant student to ever graduate from the school. I can tell you he's a very, very smart guy, and it was my good fortune to meet up with him in graduate school. And we got our degrees in engineering physics and applied physics back in the early 80s. Now, because of all the time I spent here, this is my home. I don't really think about the gray hair. I can't see it from where I am. You can see it. But I feel more like one of you than I do one of the business people that I interact with from day to day. So I want to talk a little bit about a similar experience to those that you are working on right now, and that is how to have an impact on the real world with something that you may have developed while you're here at the school. This got built part of the way through my tenure here at the school, and I wrote my PhD thesis on a yellow legal tablet in one of the top floors here looking out toward the east. This was well before laptops and that kind of thing, so it was really the old days. And it was a very enjoyable place to work. The work that we did here was around a field called excimer lasers. These are short wavelength, deep ultraviolet lasers. And in about 1987, Rick and I sat down on his kitchen table, and wrote our first business plan. This was typed by hand. And we decided we were going to focus on a new type of light source for companies like GCA, Nikon, and Canon. You probably recognize two of those three names. And interesting, there's a company called ASML that's conspicuously missing that was getting started just before we did in the Netherlands, a company that would become very important to us as time would go by. And to help provide the patterning of advanced integrated circuits in the future, they needed to move to very short wavelength light sources, and we intended to become that supplier. Lithography, what is lithography, or optical microlithography? It's a process by which you use short wavelength light with some very special characteristics. You pass it through a negative of a circuit pattern and project it with a reduction onto the surface of a wafer, a silicon wafer, which has been coated with a light-sensitive emulsion called photoresist. You then develop the wafer, leaves behind a stenciled pattern from which you etch or deposit materials, and you do that again and again, and you build up various layers of circuitry in an advanced IC, anywhere from 30 to 50 different layers of circuitry. And as time goes by, you've heard of Gordon Moore, Moore's Law. The industry has a track record of doubling the number of transistors on an integrated circuit every 18 months. That's what's kept the whole industry vital. That's what's allowed for faster, smaller, cheaper devices that we use every day in our everyday lives. And it's governed by a very simple equation that the resolution is proportional to the wavelength of light divided by the numerical aperture of the lens projection system. This is the speed of the lens. So you make a faster lens, low F number, or you reduce the wavelength of light. Companies like Zeiss and Nikon work on this part. Companies like Cymer work on the wavelength part. This is Rick Sandstrom. We rented 200 square feet of office space up in Encinitas many years ago, and that was the state-of-the-art of CAD systems at that point in time. This is some of the machine shop that built some of our first parts. The tall, thin guy without gray hair is me. And Jim Billups is an ex-UCSD physics student who decided to stop after 4 years and start a high-tech machine shop. Did a lot of work for NASA and UCSD Space Sciences. But we also built a lot of stuff at the UCSD machine shop. This school built tens and tens of thousands of dollars of parts for us on the sly, and years later when we got our first venture capital financing, we paid them back. So UCSD Machine Shop was really one of our early angel investors, if you will. So we worked for several years, 5, 6, 7 years, and in 1993, we finally had what we saw was the first small impact on the real world. We had about 80 people at that point in time, and Industrial Light and Magic started to use some IBM workstations that had IBM PC microprocessors in them, Power PCs. They were the most powerful at the time. They'd been built using wafer steppers with Cymer's light sources on them, and they used that to do the T-Rex scenes in Jurassic Park. So when we heard about this, we got all 80 people in cars and drove down to UTC by the ice rink there and watched Jurassic Park. And it may be funny to you, but we thought it was really something because we had been working in obscurity and finally this little impact on the real world. So we knew that we were starting a company in a really terrible neighborhood. The semiconductor equipment industry is a tough business. It's characterized by a small customer base. Those customers, however, are global companies. They're very large. They're Samsungs and Toshibas and Intels and so on and so forth. Because of the fast speed of Moore's Law, what you do today is obsolete within a year. You have to continuously vet your company on the next generation and invent. The business is highly cyclical, so you have to have a business model that's low on the fixed cost side, high on the variable cost, and be able to withstand swings in revenue of 30, 40, 50% that can occur within 2 or 3 months and can last for 2 or 3 years in duration. And because of this, on the venture capital side at least, there's been poor capital availability. So we understood some of this, but we also thought we had a better idea, and we didn't think the world knew about us because we were so obscure. And we set to work. And this is what happened. 10 years to become an overnight success is what it looked like from the outside world. Inside the company, this period of time, of course, was living hell. It was raising money from one venture source or another in desperation to keep the company going, selling an extremely small number of tools that were being used by chip makers for prototype development purposes, but no volume production. The chip makers found ways of using the old technology, which used an old simple mercury bulb as a light source, and pushed it further and further. But then around 1996, that old technology ran out of steam. It could not go any further, and we found ourselves kind of the center of the universe. We had every chip maker in the world come to visit us and help tell us how it was we were going to scale our manufacturing. And we went from almost nothing to a large number of unit production virtually overnight. So this is when the ignorance becomes the vision part. From the outside, it looks like you were highly visionary. In reality, you were stubborn and had a lot of good luck. And so in 1996, to raise money to make sure that we could finance this, we went public with Morgan Stanley on the left, Montgomery on the right, and Needham in the middle. And it says Red Carpet Lounge anywhere in the world. I highly recommend to every physics graduate, if you can be part of an IPO roadshow someday, you should definitely do it. It's an experience you won't forget. It's usually 7 to 10 days. We started in Europe and finished in the United States for a total of about 10 days. And you're up at 4 o'clock in the morning, meetings starting at 6:30. You do typically 12, 45-minute presentations to some of the smartest, most insightful investors you'll ever meet. And they have piercing, difficult to answer questions. And you do that over and over again. You fly to a new city, you do it again the next day. And by the end of the experience, you're completely exhausted, but totally exhilarated. And we were fortunate to get about a 12 to 15x oversubscription. We went public at about $9 per share, and within 12 months, we were about $90 per share. So it was a very successful experience for us, and it gave us the capital that we needed not only to pull off the manufacturing ramp, but to convince chip makers in the world that we were secure enough from a balance sheet perspective that they could count on us to support their next generation of factory construction. Remember, chip maker factories cost billions of dollars, largely because of the expense of the equipment that goes into them. That was, by the way, that's Bill Angus, our CFO at that time, sitting next to me. So we launched into a series of products in '96. This was our first one. And over time, the products got larger, more powerful, more sophisticated. We still build a variant of this particular product. It's an argon fluoride excimer laser, spectrally narrowed, actively stabilized, two-chamber, multiple pre-pulse operation, a very complex technology. Sells for about $2 million per copy. This is about the size of 4 upright refrigerators placed side by side. And in the middle of the screen to the left is our most recent technology. It's not a laser. It's called an extreme ultraviolet source. It's very complex and large. This and its equipment to run it occupies half of a tennis court in size. So it's a big piece of equipment. It ships in 60 large crates. It ties up several of all of the fuselages of some of the largest aircraft when you ship it overseas. And our focus has been on, again, racing to technology. We spend a lot of money on technology development. More recently, spending 35% of revenue on R&D, which is almost unheard of in today's world. This shows with effective Moore's law over this period of time, and the number of transistors on the vertical axis here. Our products have helped to enable and pattern chips going from about 10 million transistors per chip, now up to multi-billion transistors per chip. EUV gets started here somewhere after 28 nanometers, which is somewhere between 28 and 10 nanometers is probably the extent that optical lithography can push it. EUV will come in with very short wavelength light, will push us to the many tens of billions of transistors per chip for obviously incredible density storage in memory chips and extremely capable, fast, and low power consumption microprocessors for portable consumer electronic devices. This is what really drives our business, the fact that all of us have all these products in our pockets and strapped to our body. We wouldn't know what to do without these kind of electronic devices. Again, when I was here, if you had an HP 45 calculator on your waist, you were considered a nerd. We're proud to have worked in an industry that has helped make being a nerd cool. And we're all nerds today and proud of it. This is showing the future of the NAND business, the NAND flash business. And because it's doubling every year, it always looks like you're right on the cusp of an incredibly exciting marketplace, and you are. And because of our market share, virtually all the chips that are built today and every one of the devices that you have in your pocket, or your laptop, or your video game, or your tablet, are all built with Cymer's light sources, and we're very proud of that. This is another picture of our EUV source that we're spending so much money on. We're the leader in this technology in the world. And because of this leadership position, we got a lot of attention from our largest customer, ASML. And a few months ago, they started to talk to us about maybe we should get together and be a single company. So intent to merge the companies was announced in October of last year. On Wednesday of last week, Cymer was a freestanding public company, founded in 1986 in Rancho Bernardo. You see our customers listed there, about 1,300 employees, and about 3,000 tools in production. We had revenues of, the last few years, somewhere between $500 and $600 million. Gross margins at 53%, but operating margin low because we're investing so much of our profitability in R&D for EUV. And then on Thursday of last week, 8 days ago, we were acquired by ASML, which is the largest semiconductor equipment company and the leader in lithography tools for $3.7 billion. And hence now ASML at a glance, this includes Cymer, headquartered in the Netherlands, but of course offices everywhere, including San Diego now. We have about 10,000 employees worldwide, revenues of about $7 million. Average selling price of the scanner is much higher than the laser, about $32 million. The selling price of an EUV scanner is currently about 110 million euros, which is about 130-some million dollars per tool. When you're a chip maker, you need to buy several of these to build chips, and it builds up rapidly as a CapEx budget. And they are principally an integrator, so their gross margins model is a little bit lower than Cymer, who does more work internally. So reflecting on the experience, and relevant to, I think, you all, what have I learned along the way here? Make sure you take every class you can, meet every person you can, and don't stop when you leave the university, because believe me, everything you learn will be of help to you. And I can't tell you how many times I've asked that question earlier on. I think my literature degree may be as valuable or more valuable than my physics training, because I'm in the job and part of communicating to customers, to investors, what it is we do for a living, and convincing them that putting their money in our company is the right thing to do. Genius is good. Passion, willpower, and good fortune are better. A lot of people want to start a company. A lot of people want to be successful. Do you have the will to actually live with the ramifications of those decisions and see them through? And can you live for 10 years scraping by, convinced that you're right and that your company is going to be successful? That's more important than being smart. We didn't believe the forecasts in this industry when we got started, because they knew that we didn't exist and we knew things that they didn't know. So when you look at market forecasts, remember they don't take you into account. You're the big variable in the equation, and you can change those forecasts. And lastly, never doubt that a small group of people can change the world. Indeed, it's all it ever has. A very commonly repeated sentence here. But at Cymer, we feel this every single day. 5 people in a room can change the world. And if you get too many people in that room, you won't. So as a UCSD student to UCSD students, I would say best of good fortune to all of you in your activities. The strongest resolve to all of you in making your business successful. And I have no doubt that in a few years, some of you will be down here presenting to a group like this. Hopefully you'll have less gray hair, because it won't take you so long. And they'll find your words, I'm sure, inspirational as to how that you've changed the future. So thank you very much for your time this morning.